Okay, last video for section R.8, and this is rational exponents. And let's just start by talking about what 1 is. So if I'm looking at something like a to the 1 over n, this is the same as the nth root of a. Also, if I have a to the m over n, this is the same as the nth root of a to the m power, or the nth root of a to the m power. So, in other words, it doesn't matter if I look at a to the m and then apply the nth root, or if I take the nth root of a and then take it to the mth power. Alright, so sometimes that looks a little bit funky when we're talking about roots that are n's and m's. So let's take a look at a couple numbers, and I think this will make more sense. So if I have something like a to the 1/2, this is the same as the square root of a. Likewise, if I had x to the 1/3, that's the same as the cube root of x. Now, when I introduce a numerator to that fraction exponent, so if I had something like x to the 2/3, that means, again, the denominator tells me the root, and the numerator tells me the exponent. So this could be the cube root of x squared, or the cube root of x squared. It doesn't matter which way you apply this. So again, I can take x to the 2nd power and then apply the cube root, or take the cube root of x and then square it. Either way, it'll work out the same. So let's say we have something like 27 to the 1/3 power. So this means the cube root of 27, which we know is the cube root of 3 times 3 times 3, or 3. So now if I looked at, say, 27 to the 2/3, then I would be looking at the cube root of 27 squared. So it doesn't matter. You can look at this. You can say, well, would it be easier for me to square 27 and then apply the cube root? Or is 27 something I can easily take the cube root of and then square that number? And often it's easier to take the root first. So since we know the cube root of 27 is 3, then this is just 3 squared, or 9. So when we're dealing with rational exponents, often it's easier to deal with the exponent versus the radical. And you'll just see as we work some different problems, you can choose to use whatever makes simplifying or solving the problem easier for you. So basically with these kind of examples, what you need to keep in mind is everything we've talked about in terms of laws of exponents to this point. They apply now. So you're going to be asked to do similar type problems. What makes them more difficult is that now you're dealing with adding and subtracting and multiplying fractions versus integers. And so it does increase the difficulty a little bit. But let's take a look at a couple different examples, and then that'll be a wrap. All right, so let's take, how about 125 over 64, and we'll take this to the negative 4/3 power. All right, so what does that mean? I would approach this the same way I would have approached any other problem involving exponents that we've looked at. This would mean 125 to the negative 4/3 over 64 to the negative 4/3. So go ahead and apply that outside exponent to everything inside. All right, now what does negative exponent mean? This actually means that this is 64 to the positive 4/3, and this is 125 to the positive 4/3. So we rearrange things. So now I've got myself down to positive exponents. Now apply what this means. All right, so this means the cube root of 64 to the 4th power over the cube root of 125 to the 4th power. Okay, I can take the cube root of 64. That's actually going to be 4, because 4 times 4 times 4 is 64. So this is the same as 4 to the 4th. The cube root of 125 is 5. So this is the same as 5 to the 4th. And now I can just take those numbers to their respective exponents. So 4 to the 4th, and you can use a calculator, is 256. And 5 to the 4th is 625. So moving along, same thing. You just need to recall what you already know about exponents. So you may be asked to simplify an expression involving rational exponents. So let's say we have something like 8x to the 1/2 y to the 2/3. And we'll take this all to the negative 1/3. And then this is divided by, how about x to the negative 2, y to the 1/3. So really there's nothing new. The only thing that you need to be aware of now is that we have fraction exponents. So when we add exponents together or multiply or subtract, we're dealing with fractions. So I would go about this exactly the same way as we did before. We need to take that 1/3 exponent to everything inside the parentheses. So this is 8 to the negative 1/3. X to the, and we multiply in this situation. So if it helps, you can just write it out. 1/2 times negative 1/3, and then y to the 2/3 times negative 1/3. And let's see, on the bottom we just have this x to the negative 2 and y to the 1/3. All right, so let's multiply those fractions. All right, we still have that 8 to the negative 1/3. Let's leave that be for now. Let's go ahead and multiply here. So 1 times negative 1 is negative 1, and 3 times 2 is 6. And then with the y, 2 times negative 1 is negative 2, and 3 times 3 is 9. And then on the bottom, there was nothing to do, so let's just write that down. All right, so now, give myself a little bit more space. Let's bring negative exponents in the numerator to the denominator and any in the denominator up to the numerator. So that means that 8 will come down as 8 to the positive 1/3. The x to the negative 1/6 will come down to x to the positive 1/6. And the y to the negative 2/9 will come down like that. The x to the negative 2 on the bottom will now come up to be x to the positive 2, and that y to the 1/3 will stay exactly where it is. So now I just need to get myself to where I'm going to go ahead and simplify the 8 to the 1/3. I want one x and one y. Okay, so what does 8 to the 1/3 mean? It means the cube root of 8. So that's just 2. Okay, now x's. So this will be, I have more x's on top than on the bottom. So this will be on top, x to the 2 minus 1/6. And on the bottom, I'll have y to the 2 over 9 plus 1/3. So now really all I have to do is perform the arithmetic in this exponent and in this one, and I will be finished. So let's go ahead and do that. So I have x to the, all right, we'll do some scratch work over here, 2 minus 1/6. So my common denominator will be 6, which means I need to multiply top and bottom by 6. So this is 6 times 2 is 12, minus 1 over 6, so that is 11 over 6. So that's my exponent here. All right, I've got a 2, and then the y, I need to add 2 over 9 and 1/3. Okay, common denominator will be 9, so I need to multiply this by 3. So this becomes 2 plus 3, or 5 over 9. So this is y to the 5 over 9. And that's it. I have my 1x, my 1y. I simplified my rational exponent. So really what you want to check here, again, is that you have the 1x, the 1y, and that we have positive exponents. So this is simplified. Like I said, there's really nothing new. We just are now dealing with fractions. Okay, so last you try. Let's try this one. Okay, 27 x to the 1/3 y squared all to the 1/3 power, and we'll divide that by x squared y to the negative 1/3. So give that one a try. Again, put all those you tries on a separate sheet of paper. We will take a look at those in class, and I will collect them on Monday. So that's a wrap.